Let us study today determinants and matrices. First, we'll begin with determinants. And let us see how to calculate the value of a determinant. Let's say A is equal to A, B, C, D. Now A is a determinant of the order 2 by 2. Now what is the meaning of 2 by 2? It is the first 2 is number of rows and the next 2 is number of columns. Now if you see, AB is row 1 and CD is row 2. If I have to see columns, A and C is in column 1 and B and D are in column 2. So A is a determinant of the order 2 by 2. Number of rows into number of columns will give you the order of the determinant. Now for a 2 by 2 determinant, when we have to calculate value, it is written as determinant of A, or it is also written as determinant A is equal to, for the above determinant, the value will be AD minus BC. It is the cross multiplication between the diagonal elements, and the operator in the middle is a minus sign. So the value of a determinant when it is a 2 by 2 determinant is AD minus BC. Cross multiply the diagonal elements and the sign in the middle will be a minus sign. Let's take a simple example to see how the value of a determinant is arrived at. Let us say A is equal to 3, 1, 4, 7. Now how do you calculate the value of determinant A? So determinant A is equal to cross multiply 3 into 7 minus 1 into 4, which is equal to 21 minus 4, and the answer is 17. So value of determinant A is 17. Let's move on to a bigger determinant. Let's say the order of the determinant is a 3 by 3 determinant. So again, let's say A is equal to 7, 2, 4, 1, 3, 1, 0, 2, 7. Now here the order is 3 by 3. There are 3 rows and 3 columns. Now how to find the value of determinant when the order is 3 by 3? Okay, let's see. Determinant A is equal to the first row. We begin from there. Take the first element. First element is what? 7. Write 7. And once you have taken the first element 7, delete the row and the column that includes this 7. So that is this row is deleted and this column will be deleted. So what is the remaining elements now? That you have to form a 2 by 2 determinant, that is 3, 1, 2, 7 minus, let's move on to the next element in the first row, that is 2. So you write 2 and again delete the row and the column containing this 2. So if I form another 2 by 2 determinant, what are the remaining elements? 1, 1, 0, 7 and plus the next. The element is 4, so you write 4 and delete the row and the column containing this 4 and you have the remaining elements 1, 3, 0, 2. Now remember, the first sign in the middle is a negative sign and the next sign is a positive sign. For calculating value of a determinant of the order 3 by 3, you always have to apply first the negative sign, then the positive sign. Okay. Now let's see what happens further. This is equal to 7. Now we already know how to calculate determinant of the value 2 by 2. So that will be 7 into. Again, you will cross multiply and the sign in the middle will be negative. So 3 into 7 minus 2 into 1. Moving to the next, sign in the middle is minus 2 into bracket. Again, cross multiply 1 into 7 minus 0 into 1. Moving further, plus 4 into bracket 1 into 2 minus 0 into 3 is what we get. If we solve further, that is equal to 7 into 7 3s are 21 minus 2 1s are 2 minus 2 into bracket 7 minus 0 plus 4 into bracket 2 minus 0. The next step, this is equal to 7 into 19 minus 2 into 7 plus 4 into 2. This is equal to 7 into 19 is 133 minus 2 into 7 is 14 plus 4 into 2 is 8. And finally, if you solve this, 133 minus 14 plus 8 is equal to 127. This is the value of determinant A, 127. Let's move on to the next, and that is matrices. And first, let's study addition. Let's say there is a matrix A which is a 2 by 2 matrix. 2 0 1 1. and there is another matrix B is equal to 4, 3, 2, 7. Then how do you add these two matrices? A plus B is equal to. Now what you do is add the corresponding elements. This 2 will be added with this 4. 2 plus 4 is the first element. Then this 0 will be added with this 3, that is 0 plus 3. The next 1 will be added with the corresponding element of B, that is 2. So 1 plus 2, and finally the last element 1 will be added with the last element here, that is 7. 1 plus 7. If you add up, the answer will be 6, 3, 3, 8, and that is addition of the two matrices. Let's see how it works for a 3 by 3 matrix. A is equal to 0, minus 3, 4, 3, 1, 1, minus 2, 7, 9. And B is equal to 4, 4, 8, 7, 1, 3, minus 1, minus 1, 0. The same thing you have to follow for adding 3 by 3 matrix. So if I have to find out A plus B, that will be equal to add the corresponding elements. So it will be 0 plus 4. The next one, minus 3 plus 4, and the last 4 plus 8. For the second row, it will be 3 plus 7, 1 plus 1, and 1 plus 3. And the last row, minus 2, minus 1, 7, minus 1, and 9 plus 0. And finally the answer, 4, 1, 12, 10, 2, 4, minus 3, 6, and 9 is the solution for A plus B. Moving on, let's see how subtraction works. Let's see how subtraction works. Let's say A is equal to 2, 3, 3, 5, and B is equal to 1, 2, 3, 4. Now how to calculate A minus B? To calculate A minus B, again you have to follow the corresponding rule. subtract the corresponding elements. It will be 2 minus 1 is the first element, 3 minus 2 is the second element, 3 minus 3, and lastly 5 minus 4. Solving it further, the final answer will be 1, 1, 0, 1. Okay, let's take another example. A is equal to 2, 4, 1, 3, and B is equal to 3, 1, 4, 2. Find 3A minus 2B. Now if you see, the subtraction is not A minus B, it is 3A minus 2B. So first you will have to find what is 3A. It will be 3 into the matrix A, that is 2, 4, 1, 3, which is equal to multiply 3 with all the elements of the matrix. So that will be 3 into 2, 3 into 4, 3 into 1, and 3 into 3. And the final answer will be 6, 12, 3, and 9. Now you have found out 3A. Let's find out what is 2B. It will be 2 into the whole matrix B, that is 3, 1, 4, 2, which is equal to 2 into 3 is 6, 2 into 1 is 2, 2 4s are 8, and 2 2s are 4. This is 2B. Now you have 3A and 2B. Let's find out 3A minus 2B. 3A minus 2B will be equal to 3A matrix, the value is 6, 12, 3, 9 minus 2B is 6, 2, 8, 4. Again, subtraction between corresponding elements. It will be 6 minus 6, which is 0, 12 minus 2, which is 10, 3 minus 8 is minus 5, and 9 minus 4 is 5. This was subtraction of two matrices. Let's move on to the next, that is multiplication. Now multiplication is important, and let's see how to multiply two matrices. Let's say A is equal to 1, 3, 2, 4, and B is equal to 4, 3, 3, 7. How to find A into B? The matrix A into B, AB, will be equal to. Now for multiplication, you take the first row and multiply it with the first column of the second matrix. Take the first row of the first matrix and take the first column of the second matrix, and when you multiply, you will multiply 1 into this 4, which is 1 into 4 plus this 3 into 3. This is your first element. Now to move on to the next element, you will take the first row of the first matrix, that is 1 and 3 already selected, and multiply it with the second column of B and do the same thing. So 1 into 3 plus this 3 into 7. Now you have got your first row. Same thing you have to do for the second row. Take the second row, that is 2 and 4, and multiply it with the first column. So it will be 2 into 4 plus 4 into 3 . Keeping the row constant, the column will change of B. Now it will be the second column, and again 2 into this 3, 2 into 3 plus 4 into 7. That's it. Now 1 into 4 is 4 plus 3 into 3 is 9. The next 1 into 3 is 3 plus 3 into 7 is 21. 2 into 4 is 8 plus 4 into 3 is 12. 2 into 3 is 6 plus 7 into 4 is 28. This is equal to your final answer. 9 and 4, that's 13. 3 plus 21, that is 24. 8 plus 12 is 20. And 6 plus 28 is 34. This is how you multiply two matrices. The order is very important. It is always the first row of the first matrix into the first column of the second matrix. When keeping the row constant, take the next column. Once the columns are over, then move to the next row of the first matrix and keep repeating the steps. Let's see how it works for a 3 by 3 matrix. Let's say A is equal to 1, 2, 3, 3, 3, 2, 1, 7, 7, and B is equal to 4, 2, 1, 8, 5, 3, 6, 6, 1. How to calculate A into B? that is AB. Now take the first row of A, that is 1, 2 and 3, and take the first column of B, that is 4, 8 and 6. It will be 1 into 4 plus 2 into the next element, that is 8, 2 into 8, and finally 3 into 6 plus 3 into 6. Now the first column is over. So let's move on to the second column. Second column of B is 2, 5 and 6. So again, if we repeat, it will be 1 into 2 plus 2 into 5 plus 3 into 6, and the second column is also over. You see, the first row of A is being kept constant and only the rows of B are changing. So right now we have finished 2 columns of B. Let's move on to the last third column of B and see what happens. That is 1, 3, 1. So again 1 into 1 plus next one being 2 into 3, and finally 3 into 1 plus 3 into 1. And now you have completed the entire row, the first row of the first matrix, that is A. Same procedure you have to repeat for the next row, that is 3, 3, 2, and the first column of B, that is 4, 8, 6. Now let's be a little quick. It will be 3 into 4 plus 3 into 8 plus 2 into 6. Moving on to the next column, it will be 3 into 2 plus 3 into 5 plus 2 into 6. And lastly 3 into 1 plus 3 into 3 plus 2 into 1. And finally the last row is left. Let's take the last row and the first column of B and repeat 1 into 4 plus 7 into 8 plus 7 into 6. The next 1 into 2 plus 7 into 5 plus 7 into 6. And finally the last column 1 into 1 plus 7 into 3 plus 7 into 1. That's equal to 4 plus 16 plus 18, 2 plus 10 plus 18, and 1 plus 6 plus 3, 12 plus 24 plus 12, 6 plus 15 plus 12, 3 plus 9 plus 2, 4 plus 56 plus 42, 2 plus 35 plus 42, and 1 plus 21 plus 7. Final answer 38, 30, 10, 48, 33, 14, 102, 79, and 29. This is how you multiply a 3 by 3 matrix. The next concept is minor of a matrix. Let's take a 2 by 2 matrix. Let's say A is equal to 3, 7, 2, 4. Now when you have to calculate minors, you have to calculate minors of each element separately. That is 3, 7, 2 and 4. These are the elements of a matrix. We have to calculate minors for all of these elements. Now each element is denoted by a special letter, and that is M. But M for the first element, that is 3, you have to write first of what row it is and second of what column it is. So if you see, 3 is in the first row and it is also in the first column. So 3, if we have to write it, it will be written as M11. Okay, now how do you calculate M11? It is equal to, once you select that element 3, you delete the row and column in which it is included. So delete the row and delete the column. And what is the remaining element? 4. So M11 is equal to 4. Moving to the next. The next element is 7. Now how do we denote 7? 7 will be M. It is in the first row but in the second column. So it will be denoted by M12. Now let's calculate the value of M12. Delete the row and the column in which it is included. So the remaining element now is 2. Same thing will continue for the last 2 elements. The next will be M. Now 2 is in the second row but in the first column. So M21 will be equal to, delete the row and the column in which 2 is included, and the remaining element is 7. And lastly, M4 is in the second row and in the second column. So it is denoted by M22. Okay, let's calculate the value. Delete the row and the column in which 4 is included, and the remaining element is 3. So now we can draw a matrix of minors. M11 right up to M22 are called minors. So matrix of minors will be, now M11, that is first row and first column, here will be 4. First row but second column, that is 2. Second row first column, that is 7. And M22 is 3, which is in this position. This is how you calculate a matrix of minors for a 2 by 2 matrix. Now remember, when we were writing M, let's say 1, 2, the first number denotes the row in which it is, and the second number denotes the column in which it is. And that's how you calculate minors for all the elements in a matrix. Okay, let's see how this works for a 3 by 3 matrix. Let's say A is equal to 2, minus 1, 3, 0, 4, 2, 1, minus 1, minus 2. Okay. Starting with the first element, this will be M11, and that is equal to, now delete the row and the column in which 2 is included, and the remaining elements will form a 2 by 2 matrix. 4, 2, minus 1 and minus 2. Now how do you solve this? This will be equal to cross multiply. So that will be 4 into minus 2 minus 2 into minus 1. That is equal to 4 into minus 2 is minus 8 minus 2 into minus 1 is minus 2. That is equal to minus 8, and minus into minus will be plus 2. So the answer is minus 6. This is your M11. Now let's calculate for the next element, and the next element will be M12, that is the first row but the second column, and the element is minus 1. So how will you calculate minors? It is delete the row and the remaining elements are 0, 2, 1 and minus 2. Solving this, it will be 0 into minus 2 minus 2 into 1. Cross multiply, and the sign in the middle is a negative sign. This is equal to 0 into minus 2 is 0, minus 2 into 1 is 2, and the answer is minus 2. For M13, let's see what happens. M13 is the first row but the third column, so the element is 3. Delete the row and column containing this 3, and the remaining elements will be written in a 2 by 2 matrix, and that is 0, 4, 1, minus 1. Solving this, it will be 0 into minus 1 minus 4 into 1. That is equal to 0 minus 4, and the answer is minus 4. First row is over. Let's move on to the next row, and that will be M21, which is the second row and the first column. So again, delete the row and the column containing this and write down the remaining elements in a square matrix 2 by 2. That will be minus 1, 3, minus 1, 3, minus 1, minus 2. That is equal to minus 1 into minus 2 minus 3 into minus 1. That is equal to minus 1 into minus 2 will be plus 2 minus 3 into minus 1 is minus 3, which is equal to 2 plus 3, and the answer is 5. Moving to the next element, M22, which will be equal to second row and second column. Our original matrix here A. The second row and the second column, the element will be 4. So let's delete the row and column containing this 4. And the remaining elements are 2, 3, 1 and minus 2. 2, 3, 1 and minus 2. So solving this now, 2 into minus 2 minus 3 into 1, which is equal to minus 4 minus 3, and the answer is minus 7. The next element being M23, second row but third column. Let's see our original matrix. The next element M23 will be second row third column, and that is 2. Deleting the row and the column, it will be 2 minus 1, 1 minus 1. 2 minus 1 and 1 minus 1. That is equal to 2 into minus 1 minus 1 into 1, which is equal to 2 into minus 1 is minus 2 minus 1 into 1 is minus 1, which is equal to minus 2 plus 1, and the answer is minus 1. Now what is remaining is the last row. This is our original matrix. Okay. Now what is remaining is the last row, and that is firstly M31, which is equal to third row but first column will be the element 1. So deleting the row and column, the remaining elements are minus 1, 3, 4 and 2. Minus 1, 3, 4 and 2. Now if we solve this, it will be equal to minus 1 into 2 minus 3 into 4, which is equal to minus 2 minus 12, and the answer is minus 14. The next element will be M32, that is the third row but second column. Here is our original matrix. Third row, second column, and the element is minus 1. Deleting the row and the column, the remaining elements are 2, 3, 0, 2. 2, 3, 0, 2, which will be 2 into 2 minus 3 into 0, which is equal to 4 minus 0, and the answer is 4. And lastly, M33, which is equal to, going back to our original matrix, third row and third column, that is the last element, which is minus 2. Deleting the row and the column, the remaining elements are 2 minus 1, 0, 4. 2 minus 1, 0, 4. Solving this, it will be 2 into 4 minus 1 into 0, which is equal to 2 into 4 is 8 minus 1 into 0 is 0. Answer is 8. And now we can prepare the matrix of minus. Which will be equal to, now we have already calculated from the beginning, so let's start with M11. M11 we've calculated is 6 minus 6. So M11, the position is here, minus 6. Then the next M12, answer is minus 2. And M13, answer is minus 4. So next element was minus 2 and minus 4. Moving on to the second row, that will be M21, M22 and M23. The answer is 5, minus 7 and minus 1. So filling this here, it will be 5, minus 7, minus 1, and finally the last row, that is the third row, minus 14, 4 and 8. So the answer is minus 14, 4 and 8, and this is the matrix of minus. This is how you calculate minus of a matrix. The next concept is cofactors of a matrix. For studying cofactors, we need the knowledge of minors, which we have just studied some time back. Let's take an example. A is equal to 5 minus 3 minus 2, 0. So A is a 2 by 2 matrix. As usual, let's calculate minus first. Starting with M11, which will be deleting the row and column. Answer is 0. M21 is minus 3, so deleting the row and column, it will be minus 2. M12, which will be equal to, deleting the row and column containing this, it will be minus 2. The next M21 will be equal to, M21 is the element minus 2, deleting the row and column, the minor is minus 3. And finally M22, the element is 0, so deleting the row and column, the remaining element is 5. Now let's calculate the matrix of minors. The matrix of minor will be equal to 0, minus 2, minus 3 and 5. Now remember, A, the order of the matrix is a 2 by 2 matrix. For a 2 by 2 matrix, you need to remember a specific diagram. Now understand, if this is a 2 by 2 matrix, then once you have calculated the matrix of minors, you have to change the sign of some of the elements. Now how do you change the sign? Starting with M11, that will be in this position here. Starting with this position, the first sign you will assign is a positive sign, and moving clockwise, that is in moving clockwise, you will keep changing the sign. So first one being plus, the next one minus, next one plus, and the next minus. So if you see, we have moved in a clockwise position, and starting with positive, the next one will be a negative, and you keep changing until you reach the original position. So if you see, every alternate sign is the same, or if I have to put it in another way, consecutive elements will not have the same sign. So now this diagram that you just drew will have to be applied to the matrix of minors. So your cofactor matrix will look something like this. Now understand, sign to be assigned to the first element is plus, minus, plus, minus. So tell me, plus 0, can we write it as just 0? The next one is minus 2, but the sign is minus. So minus into minus will make it plus 2. The next one is plus 5. Moving clockwise, the next element is plus 5. So I will just write 5. And the next element is minus 3, but the sign assigned to it is minus. So minus into minus will make it plus 3. And this is your cofactor matrix. Understand, this diagram is something that you need to remember. Okay. Let's take a bigger matrix, that is a 3 by 3 matrix, and see how this works. A is equal to 2, minus 1, 3, 0, 4, 2, 1, minus 1 and minus 2. Step 1 is calculating the minors. So let's finish off calculating the minors. M11. M11 is the element 2. Deleting the row and column with this will give you a 2 by 2 matrix, which is 4, 2, minus 1, minus 2. Solving it further, 4 into minus 2 minus 2 into minus 1, which is equal to minus 8 minus 2 into minus 1 is minus 2, which is equal to minus 8. Minus into minus will make it plus 2. Answer is minus 6. The next one being M12. For M12, the element is 1. So for calculating the minus, delete the row and the column containing that 1 and write the remaining elements in a 2 by 2 matrix form. So it will be 0, 2, 1, minus 2. Solving it, it will be 0 into minus 2 minus 2 into 1, which is equal to 0 minus 2. The answer is minus 2. Now if you want, since you have already studied how to calculate minus, you can pause the video here and complete calculating the minus right up to M33. I will now calculate a little faster. M13 is equal to I have calculated minus for all the elements. So I'll prepare a matrix of minus now. You can compare your answer with this matrix of minus. Pause the video here if you want, and this should be your matrix of minus. Compare your solution and check. Okay, once you have done that, now for a 3 by 3 matrix, the diagram for change in signs will be a little different. For order 3 by 3, understand how will be the change in signs. Now remember, for a 2 by 2, you moved in a clockwise position. The same thing you will follow here. The first sign is always a positive sign. So starting with the first element, it will be plus, and as you go, you keep changing the sign again. So plus, then minus, then plus, then minus, plus, minus, plus, minus, and plus. For a 3 by 3 matrix, this is the diagram to remember. So now applying this diagram to the matrix of minus, you will get your final answer, that is a cofactor matrix. The cofactor matrix, let us see how it works. The first sign to be assigned is plus. To make it a little easier to understand, the signs that we need to apply, I will write it in a different ink on the matrix of minus. So starting from the first, will be plus, minus, plus, minus, plus, minus, plus, minus, and plus. So now drawing the cofactor matrix, the first element, you have to assign a plus sign, but plus into minus is minus, so it will remain minus 6. Minus into minus is plus, so the answer will be plus 2. Plus 0 is as it is 0. Moving down, minus into minus will be plus 3. Plus 8 we can write as it is 8. Minus 4, so minus 4. Plus into minus is minus 10. Minus into minus will make it plus 1, so 1. And plus into minus is minus 7. This is how you calculate cofactor matrix for a 3 by 3 matrix. You can pause the video, go back a little, and see the process for calculating cofactor matrix. First start with a 2 by 2, then move on to a 3 by 3 matrix. The next concept is a simple concept called as transpose of a matrix. Now the idea for transpose is convert rows into columns. That's it. You just need to remember this. Convert your rows into columns. Let's see an example. A is equal to 5172. Now if I have to calculate the transpose of this matrix, it is denoted by a raised to t, and that will be the first row will be written as the first column. So 5, 1, and the next row, that is 7, 2, will be written as the second column. 7, 2. That's it. Let's move on to the next concept, and that is adjoint of a matrix. Now to calculate adjoint of a matrix, you have to calculate and apply all the things that you have studied up to now. So if I have to present it in a step-by-step pattern, the steps to calculate adjoint will be as follows. First one is calculate minors, which we have just seen. Second will be draw the cofactor matrix. Third, take the transpose of cofactor matrix, and once you take the transpose, you will have adjoint. Okay, so let's take a simple example to understand. A is equal to 5 minus 1, 2, 2. Okay. Now quickly let's calculate minus for all these elements. M11 is equal to 2. M21 M12 is equal to 2. M21 is equal to minus 1, and M22 is equal to 2. M22 is equal to 5. So the matrix of minus will now be 2, 2, minus 1, 5. Now to calculate cofactor, we will have to assign the signs. For 2 by 2 matrix, starting clockwise, first sign being the positive sign, plus, minus, plus, minus. So to draw the cofactor matrix now, this will be plus 2 written as 2, then minus 2, plus 5, and minus into minus will make it plus 1. Now that you have calculated the cofactor matrix, the next step is to take transpose. And you will take transpose of the cofactor matrix. So if you see, this was our step 1, cofactor is step 2, transpose is step 3. Remember, transpose is converting the rows into columns. So if I have to convert the rows into columns, the first row converted into column will be 2 minus 2, and the next one will be 1, 5. And this is the final answer. It is denoted by adjoint A, or simply ADJA is your final step. Applying the same thing for a 3 by 3 matrix, let's see how it works. Let's say P is equal to 3 minus 2 minus 1, 2, 1, 5 0 6 4. Starting from the beginning, step 1 is to calculate minus. So you can pause this video and quickly calculate your minus right from M11 to M33. I will quickly calculate all the elements and you can compare your answer. I have completed calculating the minus. I will now draw the matrix of minus. Again, if you need, pause the video and compare your answer with this step. What you have done is calculated the matrix of minus and you have finished your step 1. Step 2 will be calculating the cofactor matrix. Again, to calculate the cofactor matrix, we need to assign signs, starting with the positive sign and moving clockwise. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So changing the signs, plus into minus remains minus 26. This will become minus 8, plus 12, minus 18, plus 7, minus 17. Plus into minus is minus 9, minus into minus is plus 2 and 12. Finally, taking transpose of the above matrix, your final answer, that is adjoint of P, ADJ, P, will be equal to, converting your rows into columns, it will be minus 26, minus 8, 12, 2, 12, minus 18, and minus 9, minus 17, and 7. This is your final answer. Moving to the next concept, and that is inverse of a matrix. Now again, inverse, similar to adjoint, will require all your previous knowledge on determinants and matrices. I will list the steps to calculate inverse. Step 1. Calculate determinant A. Let's say we are calculating for a matrix A. First step will be calculate determinant of A. At this stage, you need to see if determinant of A is equal to 0, then the inverse does not exist. Inverse does not exist. The first part of this chapter, we studied how to calculate determinant. The value of the determinant, if it turns out to be 0, the inverse does not exist and the solution ends here. But if the determinant of A is not equal to 0, then inverse exists. If determinant of A is not equal to 0, then inverse exists. Now since the inverse exists, we have to move forward to calculate the inverse. So moving to step 2 will be calculate adjoint of A. Calculate adjoint of A, which we have just studied how we find out the adjoint of a matrix. And once you have done that, the final step to calculate inverse. Inverse of the matrix A will be denoted as A raised to minus 1. And there is a specific formula for calculating inverse of a matrix. So in our case, inverse of matrix A denoted by A raised to minus 1 will be equal to 1 upon determinant of A into adjoint of A. 1 upon determinant of A into adjoint of A. If you apply these 3 steps, third step will give you the inverse of a matrix. Okay, let's start with a 2 by 2 matrix. Let's say A is equal to 2 minus 3, 1 minus 2. Step 1 will be calculating determinant of A. So determinant of A for a 2 by 2 matrix is cross multiply and the sign in the middle will be negative. That is 2 into minus 2 minus 3 into 1. Solving further, 2 into minus 2 will be minus 4 minus 3 into 1 is minus 3, which is equal to minus 4, and minus into minus will make it plus 3. Finally, determinant of A is equal to minus 1. Now we can conclude that since determinant of A is not equal to 0, the inverse exists. Inverse exists. Moving on to step 2 is calculating adjoint of A. Now to calculate adjoint, first you will need minors. That is M11, M12, M21 and M22. So you can pause the video and calculate minus M11. The minor will be -2. For M12 it will be 1. M21 will be -3. And M22 will be 2. Once you have calculated the minors, you need to draw the matrix of minors, which will be -2, 1, -3, 2. Next step would be to calculate the cofactor matrix. Our objective is to calculate adjoint, but in order to do that, we need to follow those steps. For 2 by 2 matrix, for applying these signs, starting with plus, minus, plus, and minus. Our cofactor matrix will be plus into minus is -2, -1, +2, and minus into minus will make it +3. Finally, taking transpose, of the above, what we get is adjoint of A, which will be -2, -1, 3, and 2. Once you have found out the adjoint, now applying the formula for calculating inverse, and the formula for calculating inverse of matrix A, denoted by A raised to -1, is 1 upon determinant of A into adjoint of A, which will be equal to determinant A. We have already found out at the first step. Determinant of A, the value is -1. So applying it in the formula, 1 divided by -1 into adjoint of A is the whole matrix, -2, 3, -1, and 2. That will be equal to 1 upon -1 is -1 into the entire matrix, -2, 3, -1, 2. And finally, the answer of inverse of matrix A will be -1 into all the elements of the matrix. So that will be -1 into -2, that is +2, -3, +1, and -2. This is how you calculate inverse of a 2 by 2 matrix. The same steps will apply for finding inverse of a 3 by 3 matrix. Let's take an example of a 3 by 3 matrix. A is equal to 1, 3, 3, 1, 4, 3, and 1, 3, 4. Following our steps, step 1 would be to calculate determinant of A. The determinant of A for a 3 by 3 matrix will be this 1. We write it as it is 1 into deleting the row and column will be 1, and the remaining elements will be 4, 3, 3, 4, minus This 3, you write it as it is 3. Deleting the row and column, you have the remaining elements 1, 3, 1, 4 plus this 3, you write as it is 3. Deleting the row and column of that 3, the remaining elements are 1, 4, 1, 3. This is equal to 1 into 16 minus 9 minus 3 into 4 minus 3 plus 3 into 3 minus 4, which is equal to 7 minus 3 minus 3. Answer of determinant of A is equal to 1. So here we'll have to write a sentence that since determinant of A is not equal to 0, inverse exists. If determinant of A turns out to be 0, you cannot calculate inverse. Inverse does not exist. In our case, since determinant of A is 1, which is not equal to 0, inverse exists. Moving on to the next step will be calculating the adjoint. For calculating adjoint, you need to calculate minus and then the cofactor. So M11, M12, M13, M21, M22, M23, and M31, M32, and M33. Going back to our original matrix, what you can do is pause the video here and calculate minus of our original matrix A. Once you have calculated the minus, you can resume the video and compare your answer with this matrix of minus. Next step will be to calculate the cofactor matrix. To calculate the cofactor matrix, remember you have to apply those change in signs, starting with plus, moving on to minus, plus, minus, plus, minus, plus, minus, plus. Two consecutive elements will not have the same sign. You have to keep changing the sign. So applying these signs, it will be plus 7, minus 1, plus into minus is minus 1, minus 0 is 0, plus 1, 0, plus into minus is still minus 3, here minus 3 and plus 1. This is your cofactor matrix. Next step, for calculating adjoint, you need to take transpose. Taking transpose of the cofactor matrix, you will have adjoint of A, which will be 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1. Converting the rows into columns, you get adjoint of A. And finally, answer for calculating inverse of matrix A. A inverse, again the formula is 1 upon determinant of A into adjoint of A. Determinant of A calculated on top earlier was 1. So 1 upon determinant of A, 1 upon 1 into adjoint of A is the matrix above. That is 7 minus 1 minus 1 minus 3 1 0 minus 3 0 1. And 1 upon 1 is nothing but 1. So your final answer, inverse of matrix A, is nothing but the same matrix. 7 minus 3 minus 3 minus 1 1 0 and minus 1 0 1. This is what you do to calculate inverse of a matrix.